Hey everyone, welcome back to another episode of the LlamaIndex webinar series. Today, I'm excited to host Charles from MemGPT, which is, basically long-term self-editing memory for LLMs. And I know the tagline in the slides is developer tooling for, building LLM agents. But basically, there's a lot of very interesting concepts in both the paper and the project itself. The project has gotten a lot of stars. The paper is very thought-provoking, and it's basically showing users how to build basically like a memory hierarchy, almost like an operating system architecture for LLMs to both like access and edit state. And I'm sure the paper and also the project has gone a lot further since I last checked it. So I'm actually personally very excited to see where the updates have headed. And without further ado, I'll pass it over to Charles.
Awesome. Yeah, thanks, Jerry. Yeah, like you said, MemGPT kind of started as this project about like memory for LLMs back when LLMs had, I don't know, let's say probably what you'd be using through APIs would be like 4K context at the time back in October. I think maybe some APIs had like 8K previews, but yeah, I mean, obviously at that point, then managing context windows is incredibly important even for basic chat applications, not even document intensive RAG or anything. So yeah, MGPT was all about with a very limited context window, how can we build some tooling on top to make sure that we can, at least for chat applications, keep like the illusion of long-term memory. But then also for document applications, have something similar where you can fit like many more, like hundreds, potentially even thousands of gigabytes of data through, I mean, it's very similar concepts to RAG, just maybe expressed a little bit differently because we started with more memory for chat. And yeah, it was so basically it was this paper from October of last year, I believe. And I guess these two figures from the paper, this is actually from the newest revision of the paper that came out a little while ago. But I think these papers are pretty kind of clear, show a pretty clear illustration of like how the system actually works. So in the bottom left, we'll see it's more of a chat application, not documents. So you might have a chat bot that asks the user, James, like, hey James, how's it going? Any special plans today on February 14th? So actually pretty great, engaging question, if you're trying to have a nice cute chat bot. But then the user says, actually, or I guess the user's not James. The user's boyfriend is James. So the user says, "Oh, James and I broke up," and then the bot immediately says, "Okay, my memory is a little bit stale. I should probably never make this mistake again. Let me go back and like write out to my memory bank and replace boyfriend with ex-boyfriend," and then has a little apology note. But it's just an idea like how you might want to be using like some sort of external memory store for an LM agent. All right. An LM chatbot agent might have like all these facts about a user that it collects over time. Also, maybe like facts about itself. We did this in the initial paper and also the initial code release. But you want the agent, for example, if the user asks the agent, like, what kind of ice cream do you like? And the agent makes up some answer, the agent should kind of write that to memory. So that if the user asks the agent again, like, what's your favorite ice cream? It has a pretty consistent response, right? It gives us so it kind of maintains a consistent persona. And then on the right, this is more about documents. So we had these experiments in the paper where we gave MemGPT the entire Wikipedia dump, which is about 500 gigs, I believe. Obviously, 500 gigs, no way you're fitting that into 4K tokens, 8K tokens, whatever, 128K tokens. So the way we handled large documents was quite similar to RAG. It's just maybe thinking about RAG more as tool use. So you like hide the RAG behind tools. And in this case, the tool is called like archival storage.search. And the LLM just is exposed to this extremely simple tool. And the tool can be like under behind the scenes as complicated as you want to make it. It could be some like crazy RAG stack. It could also just be like cosine similarity on Chroma or something. And as the key idea here is that the tools are simple and then they're also paginated. So you never blow up context accidentally. So in this case, you see the bot is looking for who won the first Nobel Prize in physics. So it searches like Nobel physics, some small, pretty reasonable search term, and it doesn't find the result on the first page of the results, and so it pages to page two. And this is kind of how all the tools in MemGPT, at least the initial version of MemGPT, were exposed. They were either like memory editing tools, or if they were search tools that brought context into the main context or external context in the main context, they were paginated, and they have some like token limit, which is maybe on an 8K on an 8K context window, the token limit might be like 3K, something like that. So you can hold maybe 3 or 4 pages. Yeah, I guess I already went over this, but especially for chat, it's like very easy to see why you want some sort of like read-write memory store, or you don't even have to call it store, like read-write memory file, for example. is if you don't have memory, like your chat applications, they'll forget key details, they'll misremember details about themselves and the user. And it's pretty obvious, like I think we have these LLMs that are really great. They're kind of like lightning in the bottle or lightning in a bottle human reasoning machines. But when users have conversations that go past, a dozen, 2 dozen messages, these issues really come up unless you're handling memory in some meaningful way. Okay, now I'll give a quick breakdown of like how MemGPT works at a pretty high level because also the code is at least I personally think pretty easy to read. It's nothing crazy, it's just like a Python runtime that sits on top of an LM. But yeah, feel free to if you have I guess I have the chat open on another screen, but yeah, if you have any questions, I can also stop to take questions. So the standard LM setup, way back from when the GPT 3.5 API was released would be you send text over to the LM and then the text comes back. But if you're thinking about it in chat completion API way, it's user text to the LM and then agent reply back from the LM. And with MemGPT, we change this a little bit. We maybe like take it one level of abstraction up, and now we call what goes into the LM events, and we call what comes out of the LM functions. So this is conveniently like JSON to JSON. And even back with like the initial iteration of like good, Mistral models, for example, I think just having like JSON to JSON, this consistent input output, ended up with like pretty clean context and inside like the context windows. And even kind of from the beginning, this kind of stuff would work with open source models. And like very quickly, as soon as people started adding like function calling data sets to their models, MemGPT became much better on open source or open weight models. Yeah, and under the hood, you still have some LLM with a limited context window. So it's not like MemGPT is a new LLM. It's just like a layer that sits on top of an LLM, and the LLM will inevitably always have some limited context. And a lot of the experiments in the paper are done with the OpenAI API, but I think there are a lot of LMs that we recommend now that work pretty reasonably well with MemGPT. Yeah, so inputs are JSON, and that means that basically everything is just going to get tagged with some metadata. And I guess in this case, yeah, a message just like how to undo git commit, something that might go into ChatGPT, for example, instead of being like a alpaca style pound user and then the user message underneath, it's going to be wrapped in a JSON object. So this is literally the string that's getting like put into the context. Like if you think about the raw context that the transformer sees. But the cool thing about like passing everything as JSON is that you can also tag other kinds of metadata, right? So you can tag stuff like document upload and type that into the transformer. And I think because everything is JSON, I think it kind of goes into, you know, LMs start to role play what they see as input. So this works pretty well. So when you send messages like document upload, you'll see like, especially if you have chain of thought, which MemGPT always has on, the LM will think things like, or output things like, oh, a document just got uploaded. What should I do with this document? So it's a pretty intuitive way to think about input messages that aren't just user messages. And we also do things in MemGPT like system alerts. So we will tell the LM, hey, you're running out of context and your memory is going to be flushed at a certain point. You should think about if you want to save anything explicitly. And yeah, like I said, outputs are all JSON, so they're all function calling. Every single time MemGPT is invoked, or the LM in MemGPT is invoked, it's always a function call. So, for example, this would be like an archival memory search. This is pretty much RAG, or you could have some really crazy RAG that powers this, or it could just be something as simple as like string matching on some file. Temporal signal into consideration. Okay, maybe you can expand. I'm not sure if I quite understand like temporal. Oh, maybe yeah. So in terms of temporal, maybe what you're asking is like, is there temporal metadata like the date time, for example, inside the JSON event package? And that is definitely the case. Yeah. So I think it might be actually turned off by default in the repo because a lot of people use like open source LMs that maybe a lot weaker than like GPT-4. But in all the stuff, all the experiments in the paper, we do include date metadata in the JSON object that flows into the LM. And it's pretty useful. I mean, like the LM can actually tell like if there's a big gap in time between the last time a user sent a message. So if the user sends a message and it's been like 5 days since the last event, it will internally think to itself, Hey, like it's been 5 days. I should probably ask, how the user's been doing over the past 5 days. The LM, oh yeah, so the LM yeah, so that's basically it. Noah. Like if the LM is going to be good at powering MemGPT, it needs to be good at function calling. Unless you're doing a ton of like constrained decoding on top to really like force the LM to be good at function calling. But yeah, we recommend using, I think on our Discord, we have a bunch of recommended LMs and they're all kind of like generic LMs that are very good at function calling. So like Mistral 7B fine tunes, like the Noose Hermes one is pretty good. They have some pretty good function calling data in their fine tuning data set. Okay. Yeah. And also these like memory editing functions are, the memory editing in MemGPT is just function calling. And yeah, that we have like in context memory and out of context memory. One way to think about it is like when a user, if as a person, when you converse with a friend, right? Like when you see a friend you haven't seen in a while, like in an airport or something, it's almost like your brain is immediately loaded with some like little persona file about that person, right? Like you immediately on top of mind, you remember like their name, their family, maybe like where they work, all sorts of things like that. But you might have like you won't immediately remember all these conversations you had a long time ago unless they like jog your memory about it. So we do have this reserved space in the LM, so in context that we tell MemGP through the system instructions should be used for stuff like that, right? So it should be used, especially for chat applications, to store like top of mind information that you should always kind of know. And that's kind of what distinguishes like that's what will make your conversations with a friend very different from conversations with a random stranger, right? Because you have like all this top of mind context. But then also there's like an infinite memory store or infinite as much as your database is infinite that the agent can also write to for less important information. And yeah, just to drive this point home that like every single output of MemGPT is a function. Even sending messages to a user is a function. And this means that sometimes if your LM is bad, it might like forget to actually send the message to the user. It might just have a internal chain of thought where it accidentally like writes the message in its internal thoughts. But as long as your LM is reasonably good at function calling, this is quite convenient because this means that like you always have chain of thought, which is pretty good for LM performance and also for planning. So MemGPT does need to like plan because it might chain function calls together. But it's also good because you might want for example an agent that like lives in the cloud or sorry lives in the cloud or on like your home server and there are more than one way there is more than one way for the agent to communicate with the user, right? Like the agent there might be like a send Discord message, a send SMS message, a send email, right? So like the agent can have its own like chain of thought, but it doesn't necessarily assume anything about how it can contact the user, that the user will see its chain of thought that's running at all times. Um, so yeah, even sending messages are functions. And yeah, basically you might have something that looks like this on the user's screen if you're hiding all the inner workings of MGPT, something like a question and then an answer. But what actually happened is like the question got packaged as JSON before it hit the MemGPT server. And then on MemGPT's side, MemGPT chained together two functions. It first, when I say chained together, I mean it like ran two LM invocations. It did a search and then it did a response. So in this case, it like searched memory for Berkeley LM meetup, and then it responded with a send message. Okay, so those are like the three main components: an event loop, functions, and a memory hierarchy. That's kind of those are the core pieces of MemGPT. If you were going to try to reproduce or rewrite MemGPT in, I don't know, some random like you rewrite it in Go or something. These are the three things you like need to implement. And like these core concepts, none of them are particularly crazy hard to implement either. So if you want to like try to implement MemGPT in Go or something crazy like that, please feel free. Be happy to help you. Um, okay, I think I will maybe pause to look at questions real quick because that's the end of this short summary. Okay,
Yeah,
so
if you want, I can also read it out loud,
oh yeah, go
just to
ahead.
filter
Yeah.
it a little bit. One of the questions is, what have you found to be the most versatile open source model for using with MGPT? And what model are you using right now?
Yeah, so I think in my experience the models change a lot, but like the model authors or like groups that are producing the best function calling models are probably Eric with like the dolphin models, and then the Noose guys or the Noose team. So I think any of their models, I'd have pretty high confidence in any model I grab from their Hugging Face that has at least like 8K, 16K context. I know some of their models actually don't. Some of them, especially Noose models, are like 4K because of data set limitations, or at least they were last time I checked. But yeah, if you just grab like an 8K model, like the flagship model off of the Dolphin or Noose research page, it should be pretty good.
Got it. I think there was another question on recency of content. So for instance, if there are similar sources in the retrieved memory that are similar in topic, but some came more recently than others by timestamp, do you account for that
Mhm.
during the retrieval process?
Yeah, that's a great question. So I think in the default implementation, if you just like run MemGPT off the shelf, it will be something extremely simple for this search tool. It'll be like whatever Chroma or PG Vector exposes as their like main search. So this is going to be like some default chunking and then cosine similarity. But in the retrieval, we do pass back metadata about like when those messages were like flowed through the context of the agent. So as long as the agent can read like UTC timestamps and do logic about them, it should be able to understand. Like it'll see its own timestamps of like when its last messages were sent, and then we'll also see timestamps of all the retrieved snippets. So it should be able to like put two and two together and realize that this is newer and it like supplants the older hit. Yeah.
This is actually a question I had. When the system spits out like an output and it does function calling, do you do like
Mhm.
multiple function calling at once, or is it just like you always do one step at a time?
Yeah, yeah, great question. So I think there's nothing in there's nothing preventing us from like doing parallel function calling in the same way that like OpenAI exposes it. We just never have really turned it on or like written the few lines of code to enable it because there's like no demand for it. But if you have demand for it, like definitely let us know and we can like write some quick code, open a quick PR to enable it. But yeah, I think the function calling is all serial. I do think the function calling being serial helps with planning, right? So I think if you've ever messed with like LM agents, you already know that like you really like they're quite finicky to work with, especially if you're using like not GPT-4, right? They're quite finicky to work with. They go off the rails really easily. Um, so you anything you can do to really kind of like constrain the determinism or like the randomness of like the things going on in the context of the agent really help. And I think one of those things is when you serialize the planning. So you only allow the agent to do one thing at a time. But at the same time, like with GPT-4 or like 4.5 or whatever, um, maybe yeah, it could do like parallel function calling with 5 steps at a time and everything would work out fine. I haven't played around with it enough to know. Yeah.
Yeah, the only reason I ask is I can imagine a scenario where basically you want to simultaneously write to your memory, but also like give back a response to the user or something. And so there could be like two things where like, one is just you want to edit your own memory, but at the same time, you don't necessarily need a block like giving back a response.
Yeah, no, that's a great point. Yeah, I should definitely yeah, I mean that's actually a fantastic reason to add it because that happens a lot. This like editing memory and then like reply immediately following up with the user or something like that. Yeah, no, great point. Yeah.
And just double checking in terms of overall time. Was the thing after this like a live demo? Because there's a bunch of questions, but we can also save them for we typically do like a 20-minute Q&A session at the end.
Yeah, yeah. Well, I think it's up to you. I mean, you've done these before, so you probably have the best gauge of like how time works. I have like a demo that probably can go as quickly as like probably 10 minutes. It's
Yeah,
basically we have an API, and then the front end that sits on top of the API, so it makes it easy to build out example apps. Like, so the one I was going to go through is like a build perplexity in 5 minutes thing, and I think it
yeah.
uses LlamaIndex web, one of the new packages with a web connector, yeah, to like download all the websites on the like search side of the tool. Yeah, but I think that will only take
Yeah,
15 minutes
yeah, that's
tops. So
yeah, that sounds great. Let's do that first, and then with any leftover time, let's answer the rest of the questions.
okay, cool. Yeah, I think I have a some random. Okay, so this is going to be context for the demo. So basically, yeah, with MemGPT, we started with long-term memory management. And one way to think about like how the order of events that happened here, it hasn't been that long, it's like since October, but like our main focus was memory. And it was a lot of it was driven by the fact that like 4K context was max at the time in many cases, at least for open source and open weights models. But to implement the memory system that we were trying to design, we built out like a full OS thing that sits on top of the LLM. And that OS not only supports memory, but it actually like it supports and implements memory via function calling, right? So it's already like a function calling native layer that sits on top of the LLMs, and also via function calling, it supports concepts like like RAG pretty natively. So since then, this is also a lot of it's like driven by our own like um, community. So there was a lot of people when we released the initial Discord bot demo with the paper. And so we released a Discord bot demo, and we also released like the CLI implementation of MGPT. And like from the beginning, there's a lot of people just asking like, hey, like I want to like run this Discord demo, or I want to run this Discord bot myself, either for fun or like to try to make some production thing on top of it, or just for my friends, like run a little chat bot on Discord server. And that actually wasn't really possible because the way the code was written for the research paper, like the CLI release, it was not like a multi-tenant, like multi-user process. You could never, there's no chance you're going to run it on, it didn't even use real databases. It was like writing in and out to like some JSON files. And the Discord bot code was like some code that was frozen in time from before the paper. It was impossible to like even migrate that code too. So a big part of what's been happening with the MemGPT project in the past month has been making this more of a service. So you now can basically you can pip install MemGPT and run MemGPT server. And it effectively has now become like a drop-in replacement for the OpenAI Assistance API. So actually this API, we have our own API partially because we wrote this before the Assistance API came out. Then the Assistance API came out, and it turns out that like a lot of the stuff they're trying to do with the Assistance API, which is effectively like the stateful agents API from OpenAI, stateful and agents, that kind of is already what MemGPT is doing. And it turns out that you can kind of we wrote like a completely compliant like Assistance API connector to OpenAI as well. So I encourage you, if you have like an app that you tried to build, or even just like toy stuff on OpenAI Assistance, you can move it over to MemGPT, and and that way, like you can like self-host the entire thing. So you can self-host it. You can use whatever LM you want. You can use custom tools. So I'm sure if you've used like OpenAI function calling, you understand that like you can't just like give the LM functions. You have to give the LM function schema, and then you yourself as the user have to execute these functions. So a big thing we've done that we always wanted to do from the beginning with MemGPT is like you just write arbitrary Python code and you give it to the LM. And because this is like self-host, you run on your computer, it's like run it at your own risk. Make sure you don't like give your agent RMRF, but it's you don't have to like separate the function execution code from the LM. It's like I think just a lot simpler to use. And the memory is also white box. So I think when the OpenAI Assistance API came out, a lot of people were asking like, oh, does this support long-term memory? Because they were hiding the context window from you. And then I think like on Twitter, it eventually got revealed that they just do truncation currently, but they're planning on eventually doing other stuff. I assume like at least recursive summarization. But yeah, I mean, that's just an example of like why black box memory is a little bit problematic if you're trying to like build production systems, right? Because you don't really like when things fail, like when your agent forgets something with MemGPT, you can just like crack open the logs and you can realize like, oh, that content was in memory, but it was just like an in context learning fail, or it was out of memory and it was like a RAG fail. With OpenAI Assistance API, it's like, well, I have no idea what happened, other than the agent just forgot. And yeah, we have a REST API, Python client, and yeah, this is pretty nascent. So um, yeah, we're looking for more users just to help us like build it out. And yeah, so to jump to the demo, if you don't know what Perplexity is, it's kind of like LLM Google with citations. Um, so it's pretty cool, really useful app, or really useful like replacement in many cases for Google. So if you ask Perplexity who won the Oscars, only interested in the big stuff, you're gonna get only the big stuff in a nice bulleted markdown list, and then you're also gonna get sources. So this is their big thing. It's like you can trust us that the LM didn't just dump hallucinations out because we're gonna link to the original sources. And how this works, Obviously, a lot of it's like going to be secrets, but presumably you can build this out by like just wrapping a Google search with LLMs, right? And so you like do the Google search powered by some SERP API or Bing API, then you do an LLM on top. So that's what we're gonna build um with the MemGPT server app. Essentially, we're gonna like build a custom search tool, and then we're going to like make a custom perplexity persona so that the chatbot answers in this perplexity style, where it gives citations and it gives like a short answer. Okay. Yeah, let me swap to share my whole screen. All right. Okay, so I kind of ran through this demo already this morning to practice, but so there might be some stale stuff here. Yeah. Well, okay. So this is all running locally right now. This is something what you're looking at right now. Hopefully, everyone's looking at what I'm looking at. But if you're looking at a screen that says like MemGPT has like a little list of agents and stuff, it looks like a playground. This is basically our version of the OpenAI playground. This should be available to download probably next week, like fully, completely free to pair with like the open source server app. And it basically is just a front end around the API that we built. So we already had this API, we've had it for a while, that allows you to like programmatically interact with MGPT. People have been building like production apps or like hobby apps on top of this API for a little bit now since it's been released, but we never had this like playground thing. I think the playgrounds are like a pretty important part of the dev experience for agents, especially because you want to like it's really hard to like tell what's going wrong, what agents have what data, what agents are like connected to what users without having some sort of like playground thing. So yeah, if you're familiar with like Playground at OpenAI, this is a very similar thing, but for MemGPT. Um, you have like your agents, you have data sources. There's nothing connected right now, so this is empty. You have tools. So the cool thing here is like you can see the tools are real code. They're not just like JSON schema. So the way this works is we still use JSON schema under the hood to like prepare a prompt for the LLM to understand how to use tools. But what you do as the user is you just write Python code. You write Python code, and then there is like a Pydantic or some like deterministic converter from this typed Python code into JSON schema. And yeah, that means that if you have Python code, it runs, you can connect it and the agent can use it. And with MemGPT, like the main way you customize agents is with personas and templates. So an example persona might be, um, yeah, like a specific kind of, I think this is a community contributed one, a specific kind of research assistant or something very simple, which is just like some AI kind of like self-aware agent thing. And then user templates are where if you're running like a multi-user service, like you're trying to run an app and the app maybe had a user login flow, and now you want the agent to like be able to see some amount of information in the user login flow, you're going to create user templates effectively. And we call these templates because every time you create an agent, the agent is going to be initialized. Its memory will be initialized with this template, but it will then be modified by the agent, right? So it's really like an initial state. So maybe when in your auth flow in this example, you collected information like first name, but you never got last name. So you might initialize this little prompt chunk as first name, Chad, last name, question mark, right? And then the LM will actually like eventually over time realize like I'm missing the last name. If I ever collect the last name, I should like rewrite this memory block. Okay. Yeah, I think that's kind of the gist of it. So the way we're gonna do this is I actually already uploaded this function, Google search. So we can take a look at like the way this works. It's basically this is also on like the GitHub repo, so you can just go grab this yourself. Um, but yeah, it's basically gonna be a tool called Google Search that uses SERP API to search Google for a query. And then when it grabs the queries, it's going to summarize. It's first going to grab the web pages with let's see, yeah, the web connector, which I think is powered by LlamaIndex. Yeah, so it's going to use this web connector, and it's going to download all the websites, and then it's going to summarize those websites, and then it's going to return at the very end to the agent the contents of the summarized websites and their links. So the agent the agent's tool it has is something where it runs Google searches and it gets back something, magical happens behind a black box, and then it gets back the summary of a few different links from Google. And then it can decide what to do with that. It can decide to like run another query, or it can decide to reply to the user, depending on like how you design the agent. So yeah, that's the Google search thing. We're going to be using GPT-4 in here just to have the least likelihood of anything going wrong. You're going to notice it's pretty slow because we're going to get rate limited a little bit. But if you ever wanted to build this out in a non like 5 minute hacky demo way, you would definitely not do this. You would use some like, I don't know, you could use Grok or something much faster. But that's just for the summarization portion. Okay. And then we also have this template, this persona template. I'll pull it up here. But this is pretty important, right? So like you need to initialize the agent's personality or persona to be this like perplexity style answer bot. So you tell the agent in the first person, you can also use the third person, but like I am a personal assistant who always answers a user's questions with web searches. When a user asks me a question and the answer is not in my context, I will use a tool called Google Search, which will search the web and return relevant summaries and the links that they correspond to. So this is so that it can return citations. It is my job to construct the best query input, to aggregate the response, and then to construct a final answer that references the original links. So this is like the second piece of this. The two pieces are you need the Google search tool that was just writing Python, and then you need to write a little prompt engineering block that it instructs the LLM how to create an answer. And of course, as a good prompt engineer, we're going to include an in-context example here so that MGPT kind of be a ham fist what it needs to do. So the user will say, who founded, oh, this should be who founded, yeah, who founded OpenAI? And then the answer will be, you know, nice, short, succinct, not super wordy because we don't want, like a chat GPT situation here. But then we get the links directly embedded. So this should be enough basically. And then there is a little bit here. This was done just for live demo sake to make sure we don't have any accidental misuse of functions. But yeah, the important thing is stuff on top. Okay. Okay. Great. So we've created that persona, and I think now that since we have the tool, all that we need to do is just create an agent. So call this LlamaIndex webinar. Okay. Initialize it with the persona. Yeah, I guess we can change this. And the last thing you need to do is just make sure that you actually like enable the tool. So any sort of tool that you ever uploaded to the server will like exist in the back end. And you can always like attach or detach tools from agents. All right. Oh, nothing has failed yet. Excellent. Okay. Yeah, so you see it has 8 core tools and 1 external tool. So the core tools are basically the main functions that we wrote in the initial MemGPT paper, which is like core memory replace, append. If you disable these, I think you might actually not be able to disable them in the web UI or in this chat UI, just to avoid people breaking their agents. But you can like customize whatever you want. But these are kind of the 8 core functions that are needed to run like the MemGPT OS. All right. Okay, so we can try. Yeah, looks like the agent's loaded. Looks like the memory has been initialized properly. Google search is enabled. Okay, so we can ask something similar, which was like, you won the Oscars. I missed them. Only. All right. So yeah, similar question that we asked Perplexity, at least the like screenshot I had. Um, okay, so this is going to take a little bit just because it's GPT-4. But yeah, this latency is like the latency of the tool. So if you're really trying to like not build this out in prod or something, you could definitely just like optimize the tool to not be so bad. But yeah. Okay, so yeah, we got a pretty similar answer, right? So you see we can also like if you want to see what the user is seeing or like what you might just show the user, it might just look like this, right? Like you don't see any internal monologue, you don't see any functions. But this is what we're looking at right now is an interface intended for devs. This is like intended for if you're deploying your agent on an app or on a service, you can see like a chat log of what's going on. You can also like interface with the agent yourself for debugging purposes. So you probably want these on. Um, but yeah, you see like the Google search function was run, and this was the return from the Google search. So um, it used it ran like a search with SERP API, then it grabbed the website with LlamaIndex, and then it summarized it with GPT-4. And you have the summary, and then you have like the source. And then that comes back to the agent, and then the agent turns that into a final answer that looks like Perplexity, right? Um, and I think yeah, this seems fine. I'm not enough of a movie buff to see if there's any like hallucinations here, but this looks basically like what we wanted. So we could ask a follow-up question that maybe shows off the memory a little bit more, like any any famous actors of my name ever win an Oscar? Let's see if it pulls the memory correctly. It should be pretty okay. Yeah, user's name is Jerry. Now it's gonna go search Google for Oscar actor named Jerry Oscar winner. That's pretty good. That's maybe like what a human might write. Um, again, slight latency hit here from GPT-4, but let's see. Okay, seems reasonable. Yeah, and this came from time.com. Yeah, legit source. Okay, yeah, and if we were rendering Markdown correctly, this should be nice and clickable, but this is, yeah, coming soon stuff. So, um, yeah. So another example would be like, actually, my name is Charles, not Jerry. In this case, it should call another function. Let's see, core memory replace to fix this. Yeah, so you see like now it says, let's go ahead and like replace the memory here to be first name Charles instead of first name Jerry, and then it's going to rerun the search. So this is an example of like how MemGPT can chain together functions. So it first did a core memory replace, and now it's going to go and do a Google search. Um, okay, yeah, again, looks pretty reasonable. So the tool is implemented correctly, and yeah, great. So that's basically how you would do this in like we're calling this the dev portal, but um, I guess the way we're using it right now is very much like how an end user would use it, but just to kind of like drive home the point that this is like a dev interface and all these agents live on a server that you can interact with programmatically with APIs. We can try sending the same agent a message, but we'll send it through curl. So what's a message that clearly requires prior context? Like, what do you think about him? Okay, so this is like a message that clearly will require some context about what we were just talking about. And yeah, I don't know. Let's turn this on, turn streaming on, make sure. Okay. All right. So yeah, let's see if this works. Post request to the same server. This should be continuing the conversation at this point. It's not going to live update on the screen, but if you refresh the chat, it should come back. Okay, yeah. So still talking about Charles Lawton. So this is just showing you that like the same agent is accessible. It's not like something that lives in a web browser, right? It lives on a server, and the way you interface with that server is an API. And this dev portal is just interfacing like with the API as well. But if you're running like I don't know, like an Android app or something, you would want to be using the REST API. So this is like server send events with that REST API. Yeah. Okay. And I think if we see if we open this agent again, yeah, there's a little bit of a timestamp bug right now that should be fixed. So the messages went a little bit out of order, but I think this is, yeah, actor named Charles. That was the last message. And then this is the one that we sent with the REST API call on the terminal. And you can see these same messages are inside the dev portal. Yeah, and I guess finally I'll do one quick thing. this is just to show off that like the vector store is connected, and it's accessible and like modifiable through archival memory. So if there had been like some sort of data sources like Wikipedia or whatever that had gone loaded into MemGPT, you would see all the fragments, all the chunks essentially in this drop-down React view. But there's nothing that we ever added, so it's empty. You put Charles's favorite actor, Brad Pitt. Stuff that in there. And now we could have something like you think about my favorite actor. Yeah, and I'm like explicitly prompting here, look for it in archival memory, just so that we don't have a prompting problem on a live demo. But the bot, if it's a good LLM, should be able to determine this itself. It'll say something like, "Oh, it's not in core memory. I'm gonna go look in archival memory instead." Yeah. So I think I mentioned this in response to a question from earlier on the live chat, but you can see like timestamps are included when you search archival memory. So this is like how the agent would reason about what fragments are where. Yeah. So Charles's favorite actor is Brad Pitt. Yeah, that came up, and that was only in memory as of a few minutes ago when we just pushed it to memory. Um, yeah, and I think I'll wrap up there. But yeah, happy to take questions now about. I'm sorry, I missed a ton of questions, and then also questions about like the server, the the dev portal, whatever. Yeah.
Yeah, this is great. I mean, obviously there's a bunch of questions, but I think everyone really enjoyed seeing the demo. And I think this is just a fantastic like visualization of how MemGPT works. And also it seems like it's a cool product for people to use. So best of luck on building this out, and hope a lot of people use it. Going through some of the top questions, I think one of the ones that I was actually curious about, which is also a question in the chat, is how is the difference between like core memory and archival memory determined? Is that just like dynamically set determined by the agent based on the prompt because you have like tools that the agent has access to, or do you make some sort of like more handcrafted heuristic decision under the hood?
Yeah, that's a great question. I mean, the basically it's all in the system prompt. So there's like a system prompt that just says, I think I'm still screen sharing, right? So you can see where I'm going here. Um, yeah, we just like jump to, yeah. So basically here, um, there's just like a human language description of how you should use the two memory banks. And there are different variations of this. There's a lot of like community contributions that have refined this. This is, I think what you're looking at now is a file that has not changed in months now. But I think there have been like community versions of it that make it better. But it's basically just done through human instructions. So you tell the agent like how to differentiate between using one and the other, the two levels of memory. And also I think in the like functions themselves, the JSON schema, archival memory, yeah, something like this, right? Make sure to phrase the memory content such that can be easily queried later when you insert. So there's a lot of like human instruction put into like random places along the way. And a lot of this is just like tuned by hand over time, like especially by community contributors who like play around a lot. That
Gotcha. Cool. Yeah, I mean that makes a lot of sense. The next question here is, and this is related to memory, this whole like memory organization, and I think it's a pretty interesting question. Is how do you think long context windows will influence WebGPT over time? Let's say 6 months to a year from now, as well as like a longer term after that.
Yeah, that's a great question. So I think like in the short term, I don't think there's a huge difference, but mainly because like long context still has pretty big trade-offs, right? Like there's a trade-off in compute and latency. If you're not doing it yourself, if you're setting it to an API, there's the trade-off in latency, right? Like Gemini 1 million, I think a lot of the demos, have some crazy like processing time. It's like 20 seconds of latency or something, or like minutes, depending on like what you're uploading. Um, but in that's like in the short term. And then I think there's also this other issue that's a little bit like under discussed with context, which is just that like even if you have millions of tokens of context, you don't necessarily like it's not always in your best interest to just like do zero work to refine that context and just dump it into the agent's view, right? Often it's like better to do a lot of work upfront to kind of refine what you're giving an LM in the context window and make it as clean as possible, especially if you want to do some like high level planning with it. as opposed to just like dumping raw, like, stream of consciousness text at it. So that implies that like even if you were to have a very long context, like the way you're going to use it will still require a lot of thought about like what should be kind of up front and center to the LM agent. And a lot of like that discussion of like what should go like, directly at the back or like right before the completion section of tokens. A lot of that conversation is going to be quite similar, I think, to like the conversation about in MemGPT, how the like what goes in core memory and what goes in archival memory. Um, so that's like for the short term ish, but I think in the long term, we're definitely gonna like 3, 5 years from now have like agent or LMs that we can use on our laptops, on our M5, M6 MacBooks, right? That support, I don't know, like I don't know, 500K million sounds reasonable in 5 years, who knows? And when we have that, I think it just means that we just have to think about the movement of memory less. Um, but all these other things like tools, like search, I think will always be issues, right? And there are always going to be things that like we have to think about, like what the loop looks like for the agent. And those are things that like we're still doing with MGPT. So I think the TLDR is basically it's only a good thing. The longer the context windows, the better, because we can just like do less of like the busy work, less of like the context organization, and more of like the fun stuff, which is more about like the problem solving, the planning, the reasoning.
Yeah, I'm interested in seeing how you like the core memory you can definitely expand, especially if you get to
Mhm.
like 1 million to 10 million context windows. And then the other part is just like, yeah, actually, the other thing is as these models get better, one thing that's very interesting is this idea of like a KB cache, right? That caches the attention activations within the LLM. And so the interaction between like any sort of external memory stored outside the LLM, as well as any like kind of inherent built-in mechanism for it storing the activations, I think is very interesting because you could think about like the core memory actually being KV cached so that like basically, during every inference call, you don't need to actually like rerun everything in the core memory.
Yeah, definitely. I think KB caching is super cool. I think you could even go one step further and think about like the ordering of the tokens essentially, and then like putting all the hot stuff at the back to avoid the chance of it like being modified or like modifying something at the front and having to like recompute the cache. Um, Things like that, right? I think it's yeah, it's pretty powerful and it really like can make a significant difference in terms of like a production app where you like really need to decode reasonably fast.
Mhm. Um, there's a general category of questions that's asking like, how do you productize this more? Like, are you thinking about making it easier for users to deploy agents, having like a Vercel template where you can just like deploy a chatbot, basically? I'm curious where you think about next steps are in terms of making this more of a product for people to use.
Yeah. So basically, I'd say like our main goal, like Sarah and I, is right now is to just make like the best, like the definitive, like open source version of OpenAI assistants. Right now, that just doesn't exist, and that includes everything. That includes like the server that you can self-host, and that also includes like this dev portal that I was showing off. Um, and we want to like a big part of it is going to be making it like really focusing on self-host and making that like very viable. So if you want to build your own apps, you can just like have you can spin up an Azure instance and then we bundle everything together. So we have like a MemGPT server process Docker bundle. And you can just like deploy that with a one click maybe to like Azure and then just have that all running and you just log in to like some static IP you got and you see the dev portal and then you have an IP you can like route all these addresses, all these REST calls to. And if you already had an app that was like written on MemGPT or sorry, an OpenAI Assistance API, you can just like port. All you have to do is like change. I think like what's in the base URL in your Node or Python SDK. You just change the base URL and you can start using the API. Although I would recommend like if you haven't built anything on OpenAI Assistance API, I'd recommend using our version of the API. You can see, yeah, like right here, there's both the our version of the API and the Assistance API. In talking to assistance APIs devs, it's a really common complaint that this API is extremely hard to use. And we also agree it's extremely hard to use. So I think like to send a message, like sending a message is such a primitive concept. Like I just want to send a message to an agent that lives on a server and get it back a reply. And then in the assistance API, it's like, oh, here's 10 steps you have to do one thing. Whereas in the other version of the API, we also support it's like one step, like you saw, just one post request. But yeah, I guess to answer your question, we are just trying to make it as easy to deploy as possible and for you to like really build a production app on top of this. And part of that is the developer portal. Yeah.
Yeah, makes sense. Are your prompts like model specific, or are they general right now? Like, do you have like have you noticed like different prompts work better for different like open source or proprietary models?
Yeah, I would say the core prompts are pretty um they're not specific to any model. So like these system prompts, I think a lot of them work just as well with like GPT-4 as they do with like open source models. I think what really is tricky with open source and is always like a battle, not a battle in like a terrible way, it's just like a battle of like prompt engineering, is the function calling part. So yeah, I think like we haven't quite gotten to the point where you can just pull something off the shelf from Hugging Face and it'll be as good as GPT-4, but we're getting a lot closer. And I think a lot of what's making this happen is like these other tricks that are outside just the LM that are like, for example, heuristics that we write into MemGPT. Like if a core memory edit happened and two messages were in the queue, that indicates that like you probably, as the LM, you were intending to send a follow-up message. So then we can just like overwrite the flag that the OS generated for like an extra invocation and just invoke it anyways. So heuristics like that. And then also stuff like constrained decoding, right? So you use grammars or use guidance or something to make sure you don't have syntax errors coming out of these models. But I think when you like throw this whole this whole bag of tricks at the open source, the best open source LMs, you get really, really close to GPT-4. And then you add fine tuning on top. This is something we're also looking into, and we've been like doing this with some pretty great community contributors. But fine tuning the best open source LLMs or open weight LLMs on MemGPT data and then add in that bag of tricks, you can get that's really like starting to push into GPT-4 territory. So part of this whole like making it super easy to use MemGPT thing is we don't want to like give you a one-click deploy and then say, oh yeah, and the only way to use this effectively is a GPT-4, and you're going to run up like one agent, one person, $100 an hour on like your message stream, and you're going to hit your token limit immediately. Uh, we want to say like when you have the one-click deploy, like oh by default, you're going to download this model from Hugging Face that is like the open weights thing. But if you want to, you can also pipe it to GPT-4.
Great. Yeah, that was a great answer. And then I think the last one, actually, I might try to take a stab at, but feel free to chime in as well. I think some people are just asking, how to better integrate MemGPT with LlamaIndex. I mean, I think at a very basic level, I think you guys are using some pieces of LlamaIndex under the hood. But in general, like the overall architecture, like agents, tool use, being able to write to some sort of both like core memory as well as archival memory, we have like abstractions for each of those concepts. So basically archival memory could be any sort of like retriever on top of vector store of arbitrary complexity, right? And then we have like basic tool abstractions so that you can define like arbitrary functions and wrap them with our tools. And you can also define custom agents that can execute like stepwise, right, on top of any sort of tools that you define. And so I think it should be definitely possible to integrate this in a more like native LlamaIndex manner. And again, I think you guys are using like pieces of it, but I think that would be a cool demo. And I think if we get around to it, it'd be a cool like Llama pack to showcase on our website.
Yeah, no, I think there's definitely like a lot of these projects, there's so much like overlap and so much you can borrow. I mean, I particularly love like all the tools that are built into LlamaIndex. It makes it so easy to just like spin up like this Google search example, like spin it up incredibly fast and then just, import like a web page ingest thing from LlamaIndex as opposed to,
Yeah, there's a few of these.
you know,
Yeah, there's Google, there's Bing, there's Tably, there's Exa as well for web search, and I'm sure there's more. But
yeah.
great, I think that's a great place to wrap up. Thanks, Charles, for your time. This looks sick. Good luck on the release, and we'll be sure to promote it. And for the audience, happy Friday, and thank you for tuning in. See you next time.
Awesome. Thanks for having me, Jerry.
Thank you.